All right. So what to do? You guys, text. Can you read that? Okay.
Yeah, it's actually looks pretty good.
Nice. All right. Well, that's a plus. So I'm using Kali Linux. Kali thankfully has the Sliver client and server as part of its repos. So it's pretty easy. You can sudo apt install Sliver, and you just dash y that, and enter in your password and get the package right. This will install the Sliver client and Sliver server. So both of those are two separate commands. Um, if you want to do it from the actual like GitHub repo, which can be done as well, you can curl the what is it? Curl. I think it's HTTPS API github.com repos. Fox is doing it using the command line, but you can also just go to the repo on GitHub. But this will grab whatever like the current package is and like whatever the download URL. And so this is just okay. Well, we can pipe this out. I'm assuming I wait. Do I have JQ? Okay, I do. Cool. Q. So this is just grabbing the Sliver server and server client for Linux. Anyway, that's gonna take like 5 years. Oh, I don't have JQ. This thing fooled me. All right, that's a quick install. I'll just go ahead and go here. So it is open source by Bishop Fox. Of course, it's not going to come up first. It's a fun Magic the Gathering reference, if you aren't familiar with Magic the Gathering. But the releases are available here. The documentation for this is really nice. So I think if you aren't familiar with Sliver, the wiki that they have on their actual website, so sliver.sh, goes through first off, how to install if you want to do it from source, or if you just want to pull the actual Sliver binaries. There's a bunch of tutorials that go through. I'm going to touch on primarily getting started in beacons and maybe some of the profiles. But they also go over some of the additional things like assembly and scripting for Sliver, which I'm just not going to touch on for the time being, but we can poke at that more if we want to. And then the individual documentation for the different sections is also really useful. So if you're like, I don't know how custom clients work, it just goes over the two. There's Sliver Script and Sliver Pi, which is a Sliver library for the job, or I think it was TypeScript, and then the other one is for Python, obviously. And then they just also go over into like writing a Golang client for Sliver, like what's needed for that. So it's a pretty customizable if you need a custom agent for this. But yeah, you can pull it, but you should see either of these. I don't think there might be a Windows version of this too. I think it's only Linux. No, there's a Windows one. So if you want to set up a server on Windows or Mac, it's all Golang, so that's why it can also be cross-compiled to all these different architectures. But to start, you want to start with at least getting Sliver server to do this thing called it's unpacking assets. So you want to unpack and then force. And the assets here are going to be things like it has its own version of the Go toolchain so that it can build the Sliver agents or the implants. It also has some other additional resources it needs to load and do different obfuscation. So there's the Garble library, which I think it still uses Garble. I don't think they changed it again. But that does obfuscation for Golang binaries. That gets included in this as well. And so you force the unpack. I just do force, just make sure everything is cleanly unpacked. And then if you want to start Sliver, we can begin this using just Sliver server as it sits, or we can look at what the different options are available for this. By default, it will start you up in a interactive mode so that you can start using Sliver in the command line. But there's different other commands that the binary itself can do. I think one of the other ones you might be interested in is the operator command. And so this will actually create operator configuration files for the users that are going to be using the Sliver C2. So this is allowing, we have our team, We have one C2 server, our team server, and we want multiple people to be able to connect to that, right? So we use the operator command to create configurations for different people to connect to, and it has all the information that's needed. The operator doesn't need to really care about maybe where that C2 exists. They just slap the config into their home folder and they're good to go. So that's kind of the beauty of the configuration file. Another one that might be at least useful to know is this daemon command, which I'll show in a second for setting up a service. So if you're setting up the C2, you might want to set up the team server as a service on the Linux box that you're using. Again, we're using this on Kali, but you might spin this up in like a Docker container or some server somewhere that's going to be standalone for whatever services that you're going to have up for the team. So, you know, whatever you might need. I'll show how to use that though for standing up a systemd service. So actually, we'll just do that right now. I'm going to create a service file in etc systemd and then system, and then I think we can just call it just sliver.service, right? So for this one, we're gonna have our first unit. This is gonna be just the describing it, right? So description, let's call it sliver, and then after it's done, we're gonna care about the network targets, and then start limit interval sec. We just want it to start immediately after that. So the service that we're going to start up is going to be just a simple service, nothing crazy. Whenever it fails, we want to restart. And then for the interval, not research, restart. I think that's restart sec, I want to say. We'll just give it a few seconds to actually start up. And then for the user, we want it to run as its root. You can change this to be sliver user instead, but part of this is just it kind of gives the builder pretty much all opportunity to use whatever resources on the system, as far as if there's like files at different locations or different users on the system, especially if you're running this all from like a user workstation. You can just kind of give it wherever. And then the exec start, actually I forget where this is located. So sliver server is at /user bin sliver server. So this will be the command that you want it to run. So exec start will be this, and then we'll just tell it daemon. So that'll run it in that kind of headless service mode. And then
Good question.
Yep.
Pascal, sorry to interrupt.
No worries.
Is that start limit interval sec or is that interval sec? Because right now it's typed out as interval. FAL.
Oh, thank you. Interval. That's exactly what I meant. Much appreciated. Interval. It will yell at you usually if you get any of those wrong. It's very goofy about it.
Was somebody an English major?
It's the intervals, man. So that looks good. And then we should be able to just, chmod. What was it? Chmod 600. We need to sudo that for the service. And then we should be able to just sudo systemctl start sliver. And we can just check the status on that to make sure it's actually running. Looks like it's running. And then we can just make sure this always starts on boot up with enable. So now every time we boot up the machine, we should have our C2 server running. So this will be useful if we need to reboot the machine and we don't want to lose all of our sessions or beacons, as long as we have them actually doing reconnects. So again, talking about the operators, we're going to have to create a config. I'm just going to create one for my local user, but if you're just using this, say like from your workstation, you don't want to have multiple people connected, you don't really care about that, you can actually just use Sliver server by itself. So if we want to actually, I'm going to stop this for a second. If we wanted to use Sliver server from the command line, we can use it without actually setting up a separate client. It's going to have the same amount of commands. There might be a couple extra ones just because it's the server. But otherwise, everything you need to do, you can do from this command line. And so I'll go over what command line arguments and everything that are here when we get to the client. But before we can actually get to the client, we have to generate the config, but we also have to enable I think it's the multiplayer, I want to say. So, multiplayer, and that just enables the multiplayer mode. And then if we're over here and we want to create a Sliver operator itself, let's change that up and move this over. Oh my gosh, there we go. We can do Sliver server the operator command. And if you ever need to figure out how to use any of these, you just -H, and it's pretty verbose on like what it explains how to actually use this. So for me, I'm going to do my name. It's going to say Pascal, and then the L host is going to be whatever the listening host is for this machine. So this is important just because in the documentation, I think sometimes it shows a local host, which can be a little just, you would want to reuse that. Like you'd say like, it's localhost, but that's actually trying to tell it where to point to. So if I create a bunch of configs for people and I say that the L host is localhost, that's probably not going to give the operator the ability to connect back to my C2. So I want this to be the IP address that my C2 server is listening on. And this is the default port's 31337. And so if we're actually, Sliver, or sorry, one of my net stats, Tolton, and I'm just going to grep for 31337. We can see it is listening on, should be on all our interfaces at 31337, which is good. That's what we want. And I might just set this to be the IP address of my interface that I'm, 10, 100, 100, 129. Or I have two interfaces on here. I think it was for, I was doing some testing earlier. But anyway, it could be either of these. As long as I can reach them, I'd want to set it to that, right? For now, I am going to use 127 because I am localhost. So it's not like that big of a deal, but just keep that in mind. So server operator name, L host, we're going to do a 127001. I'm going to save it to Pascal config or .cfg. Doesn't matter. But I do have to specify an L host, which I specified. Sliver server operator. Is it because it's not a string? We get mad about that. That's crazy. Oh, I know why. I did a silly in the command. Made it separate arguments. So there we go. That should work. All right. And this Pascal config, it's just this blown up JSON file, basically. Don't share this, I guess, is from like a privacy standpoint. Anybody that has this can connect back to your to the C2, basically using this operator. So it's gonna have the token that the operator can use, and I think you can even set like expiry dates if I recall. Maybe not. But anyway, I can actually revoke operators if I wanted to. So if operators here, it says Pascal's offline. Looking at the H, I can specify maybe to remove an operator. I'm pretty sure you can in this. Forgetting how to do that off the moment. It's not often you have to like just kick off random people, but oh yeah, here we go, kick operator. So I can kick people using this kick operator command and then specify whatever the operator name is. And then now that config probably shouldn't work anymore. So if that ever needs to happen, that's something you can do. But this config's here. So like now I need to be able to use my Sliver client, right, to be able to connect. But my Sliver client actually fails to connect. It's because it's looking in this folder right here for configs. If I LSLA that folder, there's nothing in there. Sliver client has a handy command where I can actually import a configuration file, or I can manually place the config in that directory. So in order to use that, I'm just going to do import. Import, you simply pass it whatever the file is you want to import. In this case, Pascal config, and it will go ahead and import it. And we can check that folder again and see that it is there, and it should be the same file as before. So it didn't change anything, it just moved it to that folder basically. Sliver is also really good about having multiple configs. So if you have multiple operator configurations for different C2 servers, you can you can run multiple instances of Sliver client and change and specify different configs. It'll prompt you. And actually, let me do this. I'll create another config. And even though these are for the same C2, it also should give you the same type of options. Right? So when I sliver client, it'll, oh, or not. Maybe it's because it's for the same C2 and it's having problems with that. So I'll make a demonstration for that later. But basically, if you have multiple C2s, which might be useful for multiple teams, and it's the case of CCDC, because sometimes knowing which of the implants are for what team, it may not come across clearly because of the way the IPs are represented in Sliver. You might want to have multiple C2s, so that could be useful just for organizational purposes. But now that we're on here, you can see that people will be able to tell that you're on here. This is the server, but clients will also see, hey, this person's joined the game. And then if I leave, exit, Pascal left the game. And then from here, we can start creating our implants. So like I said, you can create the implant from the server, but when you create it from the client, there's a special thing that happens. You actually don't need to go to the server to actually pull the implant. You can create it and it'll pull it to your local machine. So kind of similar to how Cobalt Strike works, where the team server might exist at a particular location, but wherever the operator is, whenever they generate something using the team server, all of the artifacts from that are going to be saved to their local machine at a path that they specify. So with this, the special command is generate. And if you're ever not sure, you can look at any of the commands that are here and it'll tell you kind of what they do. You can also see, looks like what other operators are online in the same way that you could on the server, but generate, and the way you figure out how to use this, I think you can do -H as well, maybe, yeah, there we go. But you can do help, and then whatever the command is usually is the nomenclature. But this is a very verbose help guide, which is super cool. It gives you some examples of using MTLS, using WireGuard, using MTLS with multiple domains, also multiple HTTP domains, DNS even. And so you can use multiple protocols for a particular C2 configuration, which is super cool. It also goes through just looking at the different architectures and formats that you can create. So one cool thing, because this is Golang, that's where a lot of this is built out, you're going to be building, I would say, decently chunky artifacts. So just keep that in mind. They're not going to be humongous, but they're bigger than just a C artifact or a program compiled in C. But the benefit of the Go runtime is you actually get the ability to compile for different architectures and different operating systems. And so some of the examples that it shows here is like, oh, well, I can compile for Linux, for Mac, for Windows. And then there's also different formats that these executables can be in. So the main one that you'll probably run into the most is just the exe format. And I mean exe, and that's how it specifies it in Sliver, but you might be thinking of exe like Windows exe. But I'll specify it as it's executable depending on whatever the OS that it's built for. So if it's for Mac, it's going to be Mako. If it's for Windows, it's PE. If it's for Linux, it's going to be ELF. And then there's others. So there's the shared one that's going to be building a DLL or a shared object file or some sort of shared library artifact, which might be useful for things like DLL sideloading, if you're trying to do DLL injection into a process. And then there's also the service one, which, we just created a service for the Sliver server, right? But you might do a similar thing using one of the implants to create a rogue service. For Windows, it matters a little more that it's explicitly a daemonized process, because the Sliver or the Windows services have to be ran in like a particular way for them to actually be a full service. Whereas like with Linux, you can have an executable that just is a long running executable, and that run as a service in systemd, and it doesn't really care. So that's why that specificity is there. It might be needed for Windows at least. So, and then there's also talks about DNS canaries. You may or may not care about this from like an OPSEC standpoint. I think for WRCCDC, this might be kind of a fun one to see if anybody visits any of the domains that are in here. This is fun because if you have one that's your main domain, and then you have your canary domain, if anybody goes to that domain, you'll be notified pretty much right away when somebody has gone to that domain. But it requires actually having a DNS listener on there. And then once you notice that somebody has gone to that domain, you can tell yourself like, hey, somebody's analyzing this implant. It's probably compromised. It's burned. Like, let's just kill that connection, right? Or migrate or do something else with it. And profiles will show in a second. But yeah, so that's kind of the rundown of this help menu, just to help guide yourself. There is a myriad of options here. Feel free to play with any of them. If you really want to know what's going on in the executable, you can use a debug flag. I'll show that output too. But for now, we'll just create one of the two types. So you can create a beacon or you can create a session type of implant. So beacon you might be familiar with if you've used Cobalt Strike. This is the type of connection that will do callbacks periodically to a command and control instance using whatever the protocol is. So if it's HTTP or HTTPS, which you might commonly see, it's trying to emulate somebody just going to a website. The default one is more like what you might see from Metasploit, which is a session connection. And this is more of a direct, just TCP connection. If it's using MTLS or if it's using HTTP or HTTPS, it's going to be a consistent connection or a series of those connections happening constantly that's going back and forth. And so, the behavior is going to look a little different. And so it might be a fun exercise to, when you're setting up your C2, to look at what that traffic, the differences are between beacon and stager. But the commands between them should be the same. I think the main one that might differ a little bit is when you're live interacting with the C2. But let's show a generate command. We're just going to generate a simple, I'm gonna do HTTP. We'll do an HTTP, but HTTPS actually. So we'll do a secure one, and it's kind of, it denotes it a little weird. So you can do HTTP in just like the port 80 clear text protocol with HTTP in the protocol definition for whatever your C2 location is. So in this case, I want to listen on 127.0.0.1, but this could be my IP address wherever. Quickly changing it to HTTPS will actually cause any of the comms to be encrypted then using HTTPS. And these are different than MTLS, where MTLS actually will bake in a key, and it's a mutual TLS authentication. It's the key is determined ahead of time, and both sides, the C2 server and the implant, will already have an idea of what that exchange should look like. Whereas HTTPS is going to use the Diffie-Hellman key exchange to have the keys be figured out in that interaction, as opposed to having them hard-coded somewhere. So that's just generally the benefit between these. So I said I was going to use HTTPS. I'll just do HTTP for now. But you can specify the OS. I think it might default to Windows, if I recall. Actually, you should be able to tell up here what the default for OS is. Yeah, so default is Windows. But anyway, we can specify that. We can do Arch, so we can do ARM if we want to do. I think the default's x86, which makes sense. So AMD 64 or x86 should both work, if I recall. But yeah, I think at this point in the world, it doesn't matter too much which one you use for that. Format, I'm gonna do exe in this case because I want it to be an executable ELF file. And then I'm gonna skip symbols. Thankfully, they do use garble, so it's a Go obfuscator. But garble doesn't take as long as it used to when they used gofuscator, which took forever to do because of the multiple passes on each of the different compilation steps. So this is pretty cool. But it still takes time. I'm gonna skip that, and then I'm gonna save that to a location. I'm just gonna call it temp memes.elf, and we're gonna generate it. It's gonna tell you, hey, obfuscation's disabled, but we're still gonna go ahead and go through with compiling it. And notice that, even though that I am creating this on the client, it's going to be actually using the operator. I know it's kind of hard to tell that that's happening, but it's going to be using the server to actually do the compilation. It's going to send the data back. And then, because I already created this, I was testing around some stuff. I'm just going to do overwrite, but it should save it then to this location. But yeah, so that's generating an implant. And then if we want to look at the implants that we have created so far, we can see that I have done a few different test ones before this. I'll actually run that again. And we can see each of these are different executables. They have code names. And actually, if you don't rename the location, the default output name of the file is going to be whatever the code name is for this. And this, we have equal context lens, inclined limb, red, capelletti. Sometimes there's some crazy names that it creates. But anyway, it'll tell you what the type is, what OS was made for, and where the command and control exists. This might be useful if I want to pull this implant or recreate it. I think you can actually implants. I want to. I think you can actually save. Do, do, do. All right, I have to go double check that. I'm actually pretty sure you can pull an implant that has already been created before. So I can like implants and then save that one. Okay, I'm forgetting what that is off the top of my head, but we'll come back to that afterwards. Anyway, we already have this one that's here on our system. So that's ls temp memes. And if we want to double check what the file type is, because maybe we're a little self-conscious that it might be something Windows-based, we can tell it's elf. From an OPSEC perspective, remember we didn't do symbol obfuscation. So if we run strings on this, we'll get a bunch of strings that are going to be this, it's Golang, so there's going to be a lot of compressed strings. There's going to be like a giant block somewhere as we're poking through this. But as you saw, there are some dependencies that are kind of in here, dependency strings. And actually, if we just grep for GitHub, that right there already tells us right away that this is a Sliver program, and it gives us every single package that it uses inside of it. Very Golang, so that right there might be kind of an OPSEC failure if you don't want that to happen. But what I'm going to go ahead and do is actually execute it. And it didn't run. Well, that's weird. So the other part of this that you need to remember to, or you need to make sure you remember, is you have to set up a listener. So the biggest part of catching the call is having a listener. And the way you check what listeners are up is running jobs. Currently, I don't have, I have one job, but it's my gRPC, which is listening on 301 through 37. If we recall from before, that's the that's the port that's used for multiplayer. So that's so people can connect in. In order to start up a listener, we might want to just, not here, but up here, generate, what did I do? Target, or no, MTLS. There we go. That's what it was, HTTP. So we might want to go back to our command and just make sure that we follow the similar guidelines to what our command had used to make sure we're listening correctly. If you want to define a custom port for HTTP, by the way, for this generate command, you just go simply at the end here and you can do like, I don't know, 6969 or 1337 or, whatever you want. But whenever you do that, if you change it, the default port that Sliver will assume is port 80 because that's HTTP. If you're using HTTPS, it'll default to HTTPS port 443. And so I'll show that here. So if you do HTTP, HTTPS, and then we look at jobs, we see now 2 listeners are there for 80 and 443. If you want to change that, I can actually create one where say I have an HTTP listener for 1337. And now looking at that, we now have an HTTP listener at that port. So if I wanted to create another malware that actually had that as the callback port, that should work now. So if we come back here to temp memes, and actually, by the way, if you're looking at HTTP, that handler, right? There's a few other permissions not permissions, but options you can set if you need to. So you can specify, like if you added a website domain to this command for the generate up here, you can specify that all here so that it knows what website maybe to respond back to if it's for C2. Maybe I'm putting this on like an Nginx instance that's hosting a fake website. So you can set some of those options here. You can also set up how to actually do jitter if this is a beacon, for example. It should handle both beacon and session type implants just off the bat, which is pretty nice. But this one is a session. And so in order to look at sessions, we just type sessions. We can see both on the server and on the client, we receive this kind of debug command saying, hey, we got a session. Look at sessions here. We can see the same thing. I know that the output's a little scuffed, so I apologize. Look at that again. The way this is broken out, you have your ID, so it's a unique identifier versus if you've seen like Metasploit, which just goes, I think, incrementally. It'll be like 1, 2, 3, 4. So this is a more unique way of actually talking about it. For some reason, this came back as it says HTTPS. So maybe the communication upgraded to SSL. I'm not sure, but should be, I think, partly because it's using the same type of communication. It shouldn't be using HTTPS. So we can double check that though with Wireshark if we need to. And then remote address, it'll tell you where it came from. This is what I was talking about before, where if you're using this on multiple teams, the only information you're going to get is whatever that remote address was. So if this doesn't show, say, the IP address we're seeing from the outside, so like the router, the other side of the router that's public facing, if we don't see the connections coming from that point, then this might be a little confusing because we'll see a bunch of 192 IP addresses across every single team and they'll look the same, and so it'd be kind of hard to discern. I think this does show the outbound IP address, but it's actually something to double check. Then it'll do the host name, username, and so on. If we want to use one of these, so we can do use, and then we can actually tab complete the selection. So if there's multiple implants or multiple IDs, so actually if I start up another one and I run that command again, another session that gets created. Look at our sessions. And then I do use, we can tab complete between each of these and select which one we want to use. Additionally, you can also just type in the 3 letters because those are usually unique enough, and it'll just automatically figure out which one you're wanting to talk to. And so now in this, again, with the rest of using this, using Sliver, you can just run the help command, and it gives you every single command you can run on top of the normal commands that were already there in the client. But this little Sliver section will tell you what to actually run, or what you can run on the Sliver implant itself. It'll tell you that you're inside of the inclined climb, which is the implant. If we again look at the implants, inclined climb was one that got created here for HCP. So this wasn't the tart pen, but instead inclined climb was that one that just got generated. So that way you know at least what communication protocol am I talking over, what type of host might this be, aside from just whatever you're seeing from the session information up here. Yeah. So I guess this is, I'm going to pause here. I know I've been blowing through all this. Any questions on any of this so far? All right. So yeah, again, from here, you can do any amount of commands. So I can just do hello am I, it's going to figure out who it is. I can do screenshots, I can shell, I can SSH, terminate, upload. I can do a variety of things, right? But one of the other things you might be interested in, just from like a, make sure I'm actually still got things alive, from a, I guess, creation, like saving time perspective, right? Is this thing called profiles. So also, if you want to, I think if you back out of this, how do you, I forget what it is. See, there's the use command, and I think you can bgbr background. There we go. All right. So a variety of those commands, right? So that'll background us so you're out, and you should be able to run the help menu. You won't see those commands anymore, so you know you're out at least of the specific implant. But the profile. So profiles, there's none there. This will tell you how to create a basic profile. This is so you can have kind of a pre-canned set of configurations of implants, and you can just create them on the fly without actually having to think about, oh, I'm creating it with symbols or no symbols. I'm creating it with for Windows or for Linux. You know, I can just do profiles. I can say new, so create a new one, and this gives you pretty much all the same amount of flags that you might expect to see for the generation command in pretty much the same fashion. I can also set up a beacon if I wanted to, if I didn't want to use a session type. So if I did new, we're going to create that HTTP beacon that we had, or a HTTP session, sorry. So 127.0.0.1. I'm actually going to do the 1337 version of this one, and then set the OS, Windows, Arch, AMD 64, format, exe, and then what it's going to ask you to do at the end of this is name the profile. So we might say, you know, or not Windows, sorry, I want Linux. I don't know why I just started rambling off Windows there. So the profile name, I'm just going to do Linux, no, or Linux off view because it's obfuscated, and then maybe exe or elf. And then, you know, maybe you might want to denote like, oh, well, this is HTTP. And so it creates this, this implant profile, which I think these exist. If we ls sliver client, it may not actually exist in the Sliver client then. It might probably exist in the configs. Builds? No, maybe not. I forget where these configs actually get shoved in, but it gets shoved somewhere. Also, because the reason why I know that you can actually recall these executables is because they exist on every single one that gets built exists on the Sliver C2 server. So if you ever lose your executable or accidentally remove it, it should be able to just be a quick pull over. Anyway, so once you figure out, okay, well, I have this profile, I've imported it into Sliver, it's there, bing, bang, boom, right? I can go ahead and I can profiles, and when we type that, it should tell us all the different profiles we have to choose from. And again, I apologize for the broken up screen here. But it gives you the name, implant type, whether it's beacon or session, platform, the C2 that's used. Remember, you can specify multiple C2s, so you know if you have multiple here, if it's in debug mode, so on. So I can do profiles. I want to generate. Remember, that was one of the commands that you can do. So you can do generate to create implant from a profile, or I can also just remove the profile, but I don't want to do that. So I can generate. I'm going to save that location. I'm just going to do temp new memes.elf, and then yeah. Oh, oops, maybe I need to. It's a little finicky sometimes about the options and how you have to like place those. There we go. So we should now have a version of this elf built with symbols now removed, and we can I will show you what that output of that looks like. Memes. So we can see now new memes is here, and if we strings memes, we can see that there's still some function symbol information, but oh my gosh, are these names garbled? They're really goofed up, and it's kind of a pain in the butt to read. And let's see, is there any GitHub? There's no GitHub. There's no Sliver. So yeah, it's pretty obfuscated, at least in that sense. High entropy though, so keep that in mind. But yeah, so you can create that, and then what this is pretty nice is like I can, again, without thinking, I didn't really think about this. I was just like, all right, I'm just gonna profiles generate this, profiles generate that, and I can just sling through, create my Linux ones, create my Windows ones. Very similar to how in Cobalt Strike you can kind of just say generate all payloads. You can do a similar thing with a series of profile calls. It's not exactly as one click, unfortunately, but that's something you can do. So what I didn't go about explaining yet in this discussion is using the Armory or doing .NET loading yet in Windows. Those are all different capabilities or COF loaders you can use that are maybe desired if you're using Windows implants. The Armory is primarily Windows tools. It's like, I think, half of Ghost Pack, which if you aren't familiar, Ghost Pack is a set of tools that are all .NET related, which is pretty useful because you can in-memory load the .NET executable to perform any of these actions. So if I want to do something with Active Directory certificate abuse, if I want to run a Mimikatz alternative, Rubius for Kerberos interactions, you can do all that in memory by just sending the .NET managed code into the Sliver implant itself to evaluate. And so Armory actually, which is super cool. Armory by default, Sliver has their own Armory that you can use that has a lot of these already set up. And so you might see, okay, well, there's this repo, Sliver Armory, certify, sharp SMB exec, sharp WMI, sharp hound, are all as these simple runnable commands where you can do sharp hound 3 just inside of Sliver once you've loaded it. They also have them, and actually if I do see Armory, it'll go ahead and fetch all the indexes initially, and usually this is a good thing to do before you start kind of futzing around a lot with Sliver, is just to start loading up all the armory components ahead of time, because it kind of takes a second sometimes. So like I can do my .NET execute if I want to. I can do stuff that's related to Kerberos. So if I have a BOF for Kerberosting, stuff with delegation, Kerberoot perhaps. It's pretty much as simple as armory. I think it's armory. Is it install? Armory. Yeah, install, and then the command. So Kerberos will just pull a bunch of different packages. You can also search for different ones if you're like, hey, does this exist in there? Maybe I'm looking for Mimikatz. Which one had that? Well, Windows Credentials does, and we can maybe pull that in and execute that then within the memory space here. But yeah, again, probably not going to go over all this, how to use every single one of these, but hopefully this at least gets people set up and running with it. I think next time, if we do another one of these, I do want to showcase using portions of those. I'll get an implant on, like, say, Windows 11 or something, and we can poke around with using that. The other one I wanted to do was also using Metasploit to fire off as a handler for Sliver. So you can like put the you get the callback from Metasploit, kind of similar to what you can do with Cobalt Strike, where I can get a Metasploit callback and then Cobalt Strike can handle that and then set up shop. Sliver can do a similar thing and get that rolling, which is pretty cool. You just have to set everything up to point at Sliver. Yeah. If there's no questions, that's all I got.